So I'm going to try to expand on explaining serial dilutions and how to prepare and plan to make serial dilutions. And I already have another video on the general aspect of doing that. So I'm going to repeat a little bit of that and then try to get into a couple different sort of things that are a little more complicated that I find some people having trouble with. So when you're preparing a dilution of some solution in a lab, there's a couple different reasons why you may be doing that. One might be, it's called to create an end point dilution. So that's where you have some chemical that is concentrated. So let's say it's a 1000x concentration because that's what's stored in a freezer or a refrigerator or that you're going to use. It's a small amount that's being shipped to you. And now to work with it, so what you need to then generate is your working solution. And the working solution is obviously going to be, well, not obviously, usually it'll tell you, what it is. But in this case, it would say it's a 1x solution. So this is 1,000 times concentrated. This is a 1 times concentrated. So you have to dilute it. You have to create a 1 to 1,000 dilution. And that amount here is then referred to as our dilution factor. And there are a bunch of different ways you can do this. All right, so the thing is, what you have to know is the requirement of your endpoint. Like, what do you need to get in the end, and sort of plan backwards for that. And that's going to be the case with all the sorts of things that you're going to do, even if it's a series and you're going to require just the tube at the end, or is it required that you need the solution in every single tube? So every single tube is a dilution that you're creating, and you're creating a series of them, and you're going to use all of them. That's another option. That's another potential scenario. So you have to kind of know what is the end goal of the scenario. Just a single solution that you're going to use, or is it a whole number of different solutions in a series and you need all of them? That's going to be the case when we're trying to find the concentration of unknowns. Normally what we do in that scenario is we create what's called a standard curve. And then we're going to have known, I don't know how that is known. Sorry, let me get this here. Okay, a known concentrations. So multiple concentrations. We know the concentration of all the solutions, and then we find out how much light they absorb in a spectrophotometer to get absorbance. And then from that, we can later find out the concentration of unknowns. So we just measure how much light they absorb, and then we relate it to the curve, and we can get an equation, and that's a whole separate thing I have some lectures on. That's one of the reasons why we perform the serial dilutions, is to do that sort of thing in lab. And we do it multiple times in our particular class. So let's go to this simple example, the 1 to 1,000. You could do it in a single step where you simply take 1 milliliter of the original concentrated solution, but instead of adding it to 1,000, you would add it to 999 milliliters. And 1 plus 999 milliliters would be 1,000. So plus 1 equals 1,000. So then we have a 1 to 1,000 dilution. Typically when we see and we write the dilution, say like this, we could think of it also in terms of volumes. Now we can do conversions, but if we go straight to volumes and just keep it that way, the top is the amount that we add. So that's the volume added. In this case, it's 1 mil. And the bottom number is the total volume. So here I'm relating the dilution factors themselves to actual volumes. Right? So 1 milliliter is what we're going to add. In the end, we want 1,000 milliliters. So 1 plus what is 1,000? 999, so 1,000 minus 1. And that's how much, say, water we would have in here, or whatever chemical we use to perform the dilution or create the dilution with. And that might be specified in a requirement. So that's like a single step endpoint. Now the problem with this might be that you don't need a full liter or 1,000 milliliters. Maybe you only need 10 milliliters. That's it. So when you're done, you take 10 milliliters from this, and there's 990 left. And what do you do with it? Well, then you either have to store it, or you have to dump it out. And maybe it doesn't store. Maybe the solution is only good for a short amount of time. And so you really wasted a lot, of solution. Potentially, maybe you still use 1 mil of the original, but that extra is hazardous and you have to dispose of it in a special way. So you don't want to have to do that. So you might do it a different way. So that's where we get the series. So we can perform a larger dilution and end up with a smaller volume in the end. So that means also that the volume is going to be specified. So in some problems that you're given, in some scenarios, the volume is not specified. So you can kind of use whatever volume you want as long as the math works. So if 1 plus 1 is 2, that's a 1 to 2 dilution, or 1 plus 3 is 4, so that's a 1 to 4 dilution, or 1 plus 9 is 10. So for example here, a bunch of different dilutions, a 1 to 4 dilution, a 1 to 8 dilution, a 1 to 13 dilution. How would I make some of these? Using the same sort of concept that I just discussed there. Volume added to volume total. So I could say, so if I have this is my original, so let's say this is the concentrated. This is the original. And these are going to be the tubes that I end up with for each of these. So what I'm going to do is I'm going to take, in this particular one here, I'm going to take 1 milliliter from the original. Now 4 is going to be the total. So I want to create a 1 to 4 dilution. So how much water would I put in there? It would be 3. 1 plus 3 is 4. And so that would make a 1 to 4 dilution. It's very, very simple, right? So from here, if I want to make a 1 to 8 dilution, that means I'm going to take 1 milliliter from the original and add it to 7. 1 plus 7 is, 8. And that's kind of the way you just follow. If I need to make a 1 to 13 dilution, I would take 1 from here and add it to 12. 1 plus 12 is 13. So you see it really simple. It's just you're adding 1 to some number to get the total dilution factor, and that number is just 1 less than whatever your goal is. So you it's part of what's considered backward planning, which if you may or may not be familiar with. If you have an end goal, you need to know what that goal is, and then you actually start at the end. So what do I need? What do I want to have at the end? And then you go a step back. Well, what do I need to get that at that last final step? And then you kind of continue work your way back to where you are in the beginning. Say, well, here's where I am now. And this applies to anything. You want to run a race, and the race is a 13-mile half marathon. Can you run 13 miles? You can't. That's the goal, though. So what can you do right now? So you find out. You say, but that's the goal there. So you need to work toward getting to that point. You have to have an end goal in mind. If it's just to run, there's nothing, you don't know, 1 mile, a half mile, you have to have something in mind. You have to have an end goal in mind. In this particular case, the end goal is a specific concentration. You need to know that. The other part of this is said now is volume. This is because, a number of different scenarios, you might need a certain volume to do an experiment with. You need a certain amount from each of these concentrations to take and use in an experiment. If you don't have enough, you may have created dilutions that are the correct concentration, but you don't have what you need. So again, it's backward planning. You have to start off, what do I actually need? Do I need certain concentrations? And then do I need specific amounts? And so you say, yeah. So sometimes you might need a specific amount of liquid. And so I'll use this example I started off with here. So we'll kind of combine these things. So let's say in this scenario, we are creating what we call the standard curve. Okay, so we have to have known concentrations, a whole bunch of them. In addition to that, what are we going to do with them? So when we're done with creating this, we're going to have to take some of the solutions and put them in a cuvette. So a cuvette is a little, well, different machines might use different cuvettes. The ones we use in lab are these little sort of rectangular containers that hold liquid. And you could get different types of cuvettes, and they might hold different sorts of volumes. So you have some that may be called a semi-micro and only hold 1 milliliter, or they could be micro and hold less than that. Generally, ours, the ones that we use, typically need about 3 milliliters. So you're going to have to add at least 3 milliliters of liquid into the cuvette. And when you put it in the spectrophotometer, then it'll read it properly. If you don't have 3 milliliters, if you have less, then the light isn't going to strike it at the right location. It might hit it at the sort of air-liquid interface, and it's not going to work. Or it might just be going through air, not even going through the liquid in your solution. So you need a specific volume, or it doesn't work. You may have created the concentrations correctly, but the solutions are unusable. So you need to pay attention to the volume. Sometimes, in certain scenarios, that's a part of the problem that you might be given. So here's the problem that we're given. We have an original solution here of a known concentration. So this is our original. And that's at some specific concentration, which I'll add in later, I'll talk about. But what we're told here is we want a series of 1 to 3 dilutions. So that's one part of it. And we need at least 3 milliliters in each one, because that's what we need to put into the cuvettes. So going back to what we talked about earlier, so we can say, okay, a 1 to 3 dilution, how do I make that? Well, 3 is how much I need in the end. And if I'm going to add 1 milliliter to it, 1 plus what is 3? 1 plus 2 is 3, and that would be a 1 to 3 dilution. The question is, will that work in this scenario? And the answer is no, it's not going to work, right? Because if I put 2 milliliters in here, and I add 1 milliliter to it, that's a 1 to 3 dilution. So it seems good, and that's going to be 3 total milliliters, so that's what we need. Except I'm going to perform a series. That means I have to now remove 1 milliliter from here to put into the next tube. Now my total volume is going to decrease. I'm only going to have 1 milliliter. It'll still be the right concentration, but I won't have enough to put in the cuvette. So we have to do something different over here. We say, oh, well, that's not going to work, at least in terms of volume. So you would have the right concentration, just not the right volume. So what else can I do to get a 1 to 3 dilution? So we have to find out, what is the same as 1 to 3? So we have 2 over 6, right? 3 over 9. Those sorts of things make it, they're all 1 to 3, but they're just different, going to be, in this particular case, volumes. We're actually going to use these as volumes. So in our scenario here, we're going to say, oh, so we're going to do this a little bit different now. So in our planning of how to create the dilutions, I'm going to know that I need at least 3 milliliters. So if I took from my original, instead of taking just the 1 milliliter, we don't always have to take 1 mil. That's our standard, our sort of default, because it makes it really easy to see what you're doing and to relate it. But in this particular case, let's say we take 2 milliliters of the original and we add that instead to 4 milliliters of water. 2 is what we added. We go back to what we thought about before. 2 plus 4 is 6. 6 is now going to be our total. Right? That's going to be the same as 1 to 3. That's a 1 to 3 dilution. Okay, so that's our first dilution. It's a 1 to 3 dilution. And if we take our scenario and follow it, I'd have to create a series of these. And then you'd have to know how many, like a series of dilutions. And I need, in this particular example, I need 6 of them. Okay, so I need 6 of these tubes for my curve that I'm going to create. I want 6 different concentrations. So what I'll do now is simply repeat this. repeat it over again. So I'm going to say, so I'm going to take 2 milliliters from here, put it into 4. 2 plus 4 is 6. Sorry, so that's 2 over 6. It's the same as 1 to 3. What am I going to have left in here? Well, 2 plus 4 is 6. Remove 2, I still have 4. That gives me enough to put into this tube. The thing is, I could change the volume. I could say, what if I did this one here? You don't need to, but let's say you needed more for some reason. You needed more than this amount. Well, you could just up the volumes. Say, okay, I could add 3 milliliters to 6. 3 plus 6 is 9, and then that's going to work that way. Okay, so this is how you would kind of continue this along. This would be 2 mils every time. And all of these would have the 4 mils. They'd all be 2 plus 4 is 6. They're all 2 to 6, 2 to 6, 2 to 6, 2 to 6, 2 to 6 here, which is all technically 1 to 3 dilutions. Okay, and that's kind of the overall scenario. That's kind of how you would do it, and that accomplishes all the goals of the requirement. The requirement is create a series of dilutions. They're 1 to 3 dilutions. I need a certain number of them, so I'll create 5, 6, 8, however many you need. You could just extend it out. But there's another requirement, and it's a volume requirement, and I have to have at least a certain amount. So now I need to scale it and change the scale a little bit here. And so instead of just adding 1 mil, which you don't always have to add 1, so that's the first thing you need to really realize, is that it's very easy, and many times you can do that, and it works just fine. But there are certain cases where you can't do it, or it makes it difficult, or you need to do something in a different sort of way. And you can add any volume in between the tubes. It could be 2, it could be 3, it could be 5, it could be all different sorts of amounts. Usually we try to keep it as small as possible for how we handle it. And as we do pipetting in lab, we could measure these smaller volumes using pipetters, a little bit easier than larger ones. They could be a little more accurate. But it doesn't really matter as long as you meet your goal. And so you have to know what the goal is and then work back, like I said, from that. There's one more aspect of this I haven't talked about, which was part of the problem, and that is in another scenario might be, or just to add on one little bit to this, might be, an end point. Kind of like, so in this particular case, I said just 6 dilutions. But maybe the end point is a specific concentration that you're trying to get, or a some specific dilution factor that you're trying to reach. And in that particular case, what you simply have to do is, look at what it is. So what is the scenario? So in one of my examples in class, I think it's like 1 to 6,400. Okay. So now is where we're going to sort of start to combine a variety of different things. So in this example and some of the others, every tube is pretty much the same. But in this particular example, we could use or create different dilutions for some, of the tubes. So in this particular example, if your endpoint here has to be 1 to 6,400, what you can do is, often for the zeros, you could do 1 to 10 dilutions. So I might have an original solution here. One plus 9 is 10. Go from here. 1 mil plus 9 is 10. 10 times 10 is 100. Okay, so now I have this particular tube is a 1 to 100 dilution. So I've already accomplished that part. Now I need to get a 1 to 64 dilution. So I could do this by creating something else, some number times a number times a number times a number to get 64 in sort of a plan. So if I did a scenario with 2 times 2, which is 4, and I did continue to do a series of 2 dilutions. So 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is, I don't know if you could see that. Hopefully the camera didn't cut it off. But that is 64. So what this is telling me is now how many steps I need to take. So I need to go from here to 1, 2, 3, 4. There's 5 total here steps to get to 64. And you could double check this once you're done, just to make sure the numbers work out. So I'm going to go 1, 2, 3, 4, like this. But I'm not going to use 1 to 9, right? They're 1 to 2 dilutions. I'm going to continue to go with the same kind of concept here, though, that I need at least those 3 milliliters. So that means, you know, the smallest volume I could possibly work with, and I'm doing 1 to 2 dilutions. So you're getting, you know, there's a whole bunch of things here that you can get very confused about. Just remember, so if you like to do backwards planning, write down what's the dilution I want. I want a 1 to 2 dilution in this particular case. So how am I going to get that and still end up with 3 milliliters in the end? Well, if I have 3 mils to start with, and I add 3 milliliters to it, 3 plus 3 is 6, so that's 3 over 6. And that means if I take out of that tube 3 milliliters and continue the series, now 3 milliliters plus 3 milliliters is 6. Sorry, that's 3 over 6. That's also 1 over 2. I'm just going to continue this along. 3, 3. Okay. And if I look at the numbers, what do I have here? So each of these is going to be, in the end, 3 plus 3 is 6, 3 plus 3 is 6, and so on. They're all going to be 1 to 2 dilutions. So right, we'll leave it for the first one, but I'll just write this for the second. And if we multiply them out, so this is 10 times 10 is 100 times 2, so that's 200. Times 2 is 400. Times 2 is 800. Times 2 is 1600. Right? But in that scenario, I said I wanted 6400. Right? So that means I still need to do 2 more. So I actually have to add in then 2 more tubes here, and that 2 times 16 is 32, and then 2 times that would be 64. So that's kind of what you would do, is you start to draw it out, and then you check the numbers. Remember, you're adding the numbers when you add the volume, so 3 plus 3. But when you move across, as you go this way, you're multiplying. So 2 times 2 is 4, times 2 is 8, times 2 is 16, and so forth, and you keep going across. Hopefully that gives you, it's a lot of different scenarios. I could probably break this into multiple different lectures, but I'm trying to, I guess, cover maybe more things in one than I should. Some of you probably get parts of this, and some parts you don't. The main thing is, as I said, to think about the main things, a couple of different things. Plan backwards. Okay, so what do you need in the end? You have to identify that. If it's not told, if the problem doesn't give you a specific volume to end up with, or a specific concentration to end up with, then you can kind of use whatever volumes you want, as long as the math works out properly, right? So if you're getting 1 to 3 dilutions, or 1 to 2 dilutions, or 1 to 10 dilutions, and you're actually doing it, 1 plus 9 is 10, or 1 plus 2 is 3, or whatever it is that you're using, if that works out and you multiply them across, 3 times 3 is 9, 9 times 3 is 27. So if you're getting the dilutions and multiplying in this way, and adding as you add, it doesn't matter the volumes unless you're told they matter. If you're told they matter, then you have to plan for that, and you have to account for how much you're going to remove from each tube, and then how much will you be left with, how much will remain once you've removed that amount of liquid. There's problems worksheets that my class runs, and some of these are very similar to those, so hopefully you could use this explanation to help you figure it out. The main thing is, though, you do have to figure it out kind of on your own, because once you do, that's when you'll start to understand it. If you just copy down what somebody else did or follow along my exact instructions, you're never actually going to understand it, and you won't be able to solve problems for yourself when you're given new situations. So if you can just apply the basic rules of this, sort of the adding and the multiplying and the sort of backward planning and the focusing on the volumes, then it doesn't matter what concentration you're given or what volume you're requested to make, you'll always be able to figure it out on your own without looking anywhere else for help, because it really is just very simple addition of numbers and multiplication. And if you could just do those two things, you can figure out anything there is. You just have to draw it out, kind of map it out, and then check the math to see if it works. And that's it.